Hello everybody and welcome back. We're on question number 17 of the 2003 Cayley competition. That's the multiple choice competition. So I say we're on question 17. Let's have a look at it. In the diagram, the four circles have a common center and have radii 1, 2, 3, and 4. Obviously the outer one has the bigger of the radii. The ratio of the area of the shaded regions to the area of the largest circle is. So we want the area of the shaded region, so this inner dot and this outer ring, to the area of the largest circle. So that whole area, not just the part that's left out in the outer circle, but outside of the second largest circle. Okay. So to do this question, we start thinking about things. We start thinking about how can we compute this shaded region. Okay, I notice it's a circle and a ring. Well, how do I compute the area of a ring? Because I know the area of a circle, pi r squared, just take the radius, whatever that is. But for a ring is a big circle with a smaller circle cut out of it. So if I know what's called the outer radius, the radius of that big circle, and I know the inner radius of the ring, the radius of the circle that we cut out, I can use that. There's a nice formula for the area of the ring. It's basically the difference between two circular areas. And then I can get the area of the shaded region. Once I have that, I know the radius of the big circle, so then it just becomes a simple matter of working out the ratio there. Okay, so we've got a couple things to do. Let's get ourselves a brand new piece of paper. We're going to draw our picture as best we can. I know that's not a particularly good circle. But as I often say, what matters is whether or not the diagram makes sense to you. This is basically the circles. Okay. So I have this big circle, and he's got a radius of 4. And then I've got shaded in here, and I have shaded here. Okay. So the tiny dot has a radius of 1. And the ring here has an inner radius of 2 and an outer radius of 3. So that we're using all the information they gave us. We need every single radius of the circles. So we want shaded region to area of big circle. Okay, well it's really easy to get the big circle's area. It's pi r squared, where r is the radius. So the radius is 4, so it's going to be pi times 4 squared, or 16 pi. Okay? Now if I want the area of the shaded region, the shaded region is that inner dot plus the outer ring. Okay? Well, the inner dot, that has an area of pi r squared, where r is the radius, so that's going to be 1. And now the ring is basically the big circle, the bigger of the two circles, the one with a radius of 3, minus the area of the smaller circle that we cut out, which is 2. So this is pi times 1, which is pi, plus 9 pi minus 4 pi. 2 squared, of course, is 4. So this is pi plus, what's 9 minus 4? Why, it's 5. Pi plus 5 pi, that's 6 pi. So our ratio is the shaded area, which is 6 pi, to the big circle, which is 16 pi. Well, when you're working with ratios, you'll notice that I think none of the answers here are 6 to 16. None of them are. But when you work with 6 pi to 16 pi. When you work with ratios, you get the same ratio as long as you can cancel out numbers. So we've got a pi on both sides. 6 pi to 16 pi is the same as 6 to 16. Well, that's not in our answers either because we've got a common factor of 2. So we can get 3, and by divided by 2, 3 to 8. And as I recall, that is E. Let's just double check. There it is, E. So that's going to be the ratio of the shaded regions to the area of the largest circle. Okay. And that concludes question 17. Hop over to the next video for question number 18, and I will see you guys there. Thanks for watching.